Hi there, here's a little help with Unit 4, Lesson 3 practice. Let's get started. Problem number 1 talks about in this hanger, the weight of the triangle is X and the weight of the square is Y. I think the first thing that we should start with is labeling those values so that we can make sure we understand what that means. In this case, remember again, triangle is X, weight of the square is Y. So when we talk about these, all of the triangles, we'll go ahead and mark with an X. And all of the squares will mark with a Y. It says complete the equation using X and Y to represent the hangers. So when we look at this expression here on the left, we want to go ahead and check to see how many X's there are and how many Y's there are. And that becomes what we call the coefficient, or the number part of the term. When we're talking about a term, we're talking about just one of the number values within the expression. For instance, this single X up here could be labeled as 1X, should we choose to put the 1 there, but it's really not necessary because of the multiplication property, or the identity property of multiplication, that says anything times 1 is always itself. You are more than welcome to put the 1 there, but it's not necessary, it doesn't have to be there. To carry that over to the Y's, we see 3 different Y's right here. And so we would say 3 times the value of whatever Y will be. Likewise, on the right side, we see 4 X's and just 1 Y. You'll notice that that Y is sitting by itself. Now the question that comes down to is, if X is 6, what is Y? Well, if X is 6, now I have the opportunity to do some substitution. I'm going to take this equation of what was X plus 3 times Y is equal to 4 times X plus Y. And everywhere I see an X, I'm going to substitute and change that to a 6. So I'm going to replace or substitute that X with the value of 6. So I'll go ahead and show you the stuff that won't change. Everything that's in red will not change. The only thing that is going to change is the value of X. When I have a value of X that I'm substituting in next to a coefficient, I like to put it into parentheses, and if it's a fraction or a negative number, I also like to put it into parentheses. When it's not necessary, such as that first one, I'll just leave it like this. And now I have some steps to take. I need to start simplifying and solving for Y, because Y is now the unknown. So that means I need to get Y all by itself. I need to collect all my Y's onto one side of the hanger and all my X's onto the other side of the hanger. In this case now, the X is 6. Over here on the hanger, you may choose to start with the coefficients and taking care of the Y's to put them all together, or you may choose to take care of the constants, just the plain old numbers, to get them isolated together. In this case, I'm going to go ahead and eliminate 6 from the side on the left. To do that, I would have to subtract that value from the expression here on the left to make it a 0 value. But in order to make that legitimate and to maintain balance and equality in this expression, or in this equation, I have to eliminate another X or another 6 from the expression on the right. It would be a lot easier to do that if this 4 times 6 was not 4 times 6. It would need to be 24. So that would be 24, and then I can subtract my 6 from there. What that leaves me with on the left expression is 3 times Y is equal to, you'll see 3 Y's here on the left side, and you see now 3 X's, what we know now is the value of 6, and 6 times 3 is 18, and then that 1 Y there. Now, because I have only Y's on the left, only variables on the left side, I need to take the variable from the right side, this Y right here, and eliminate that. So all that I'm left with are the constant values. By eliminating that Y from this side and this Y from the left side, that leaves me, or shows me, that I'm subtracting the value of that Y to eliminate it from the expression on the right, eliminate 1 Y from the expression on the left, leaving me 2 times Y is equal to 18. And you'll see now that my two expressions have have values, terms on the left, or a term on the left and a term on the right that are not like terms. The reason they're not like terms is because the expression on the left, 2y, is unknown. I don't know what y is. And since I don't know what that product is in the end, I can't simply combine the 18 or the 6's or any other constant with it. My final step is to use the division property of equality to separate the 2 times the y, or to undo that. And we see that y is equal to 18 halves, or better answer is 9. There we go. The last thing that I can do to make sure that I'm right is I can check my answer. This is something I would like to start with early to make sure you understand how to do that. We check our solution to make sure that we have equality. Or what that means is now I can go back and I can say if x is 6 and y is 9, then that means these two expressions should be completely balanced if that's the true case. I know 9 times 3 is 27. 27 and 6 is going to be 33. So that's what my total value is here on the left-hand side, 33. Over here on the right side, we have 24 and 9, and together that makes 33. Now, since my expression on the left and my expression on the right have the same value, I've proven that these are equal, and I know that is the one solution that will make this hanger true given the numbers that I have. The other option that I can do is replace each of these y's and x's with 9. And so instead of having, the x's with 6 and the y's with 9. So instead of having x, I would have 6 plus 3 times 9 is equal to 4 times 6 plus 9. And you'll see that there's a direct correlation to this right here, 3 times 9, to right here, 3 times 9. 4 times 6 to right here, 4 times 6. I know it's a lot of drawing all over on this mess. But then we see the exact same thing on the left side as we saw over here on the hanger. 6 plus 27, 24 plus 9, right here. And then, of course, at the very end, 33 is equal to 33. Since my equation, my expressions both came out to the same ending value, after finding out what x and y are, I know that I have the correct value for x and the correct value for y. All right, it's quite a bit for one question. Let's move on to the next one. We'll move a little quicker through the rest of these. Question 2. Andre and Diego were trying to solve 2 times x plus 6 is equal to 3 times x minus 8. Complete the statement that describes the first step they each made in solving the equation. The result of Andre's step was minus x plus 6 is equal to a minus 8. Andre subtracted. Well, we think about this, what's missing or what's the same? That's still the same. That's still the same. So we know that Andre started with his variables and he started with eliminating one of them. I see that there's no variable on the right side. So this 3x has been eliminated from the right side of the equation. And he's used subtraction. So he must have subtracted, whoops, let's fix that. Must have subtracted 3 times x from each side. Where we see that Diego did a different step. On his, we see that he has the 6 that is left over here on the expression on the left, where he has x and 8. So it appears that Diego's step, rather than talking about the 3x, he instead took care of the 2x, subtracted the 2x from the side, and either way is totally fine. Either direction is just fine. It's not going to matter which one you do. They'll come out with the same result. That's the cool thing there. All right, a little bit of review, I believe, on this one, talking about the table of values that makes it, from lesson 311. Complete the table of values for x or y that make this equation true. Write fractions in the form a over b as necessary. Here's a big thing right here is that answers, if they're not in fraction form, then it's going to be counted wrong. We have to follow directions for this. So now what does all this mean? Well, it means that we're using substitution. I hope this is not a new concept anymore, but substitution means that I'm given a value such as 2. I need to plug it into the equation, or replace the x value in this case with the given value. And then I need to just solve for y. 3 times 2 is 6, plus the value of y is equal to 15. To find that value, subtract the 6 from both expressions, maintaining equality. This is called the subtraction property of equality. And y has to be equal to 9. There we go. Now, what if y is 3? Okay, well, if y is 3, then I would take 3 times the value of x, add the value of y, which is 3, to equal 15. Now, again, we're still trying to find the variable. In this case, we're trying to determine what x is. So we need to simply subtract the 3 to eliminate the constant from the left, join it with the constant on the right, so we have all of the like terms separate from each other. Use division property of equality, and we find out that x must be equal to 4. All right. I do want to point out a couple of items in here. This one right here, very important to pay attention to. We have a 0 right here. That makes this the y-intercept. And it makes it kind of cool because I really like using the zeros, because what I can do with this, I would normally, if you could see me do this, it's a cover-up method, but I know anything times 0 is equal to 0. So when I look at the equation 3 times x equals 15, or 3 times x plus y equals 15, when I see that x is 0, that term is basically eliminated because of the zero product property. And then I can look at the equation, or what's left of the equation. I simply see that y equals 15. Pretty quick and easy on that one. I'd like to next look at this one right here, where I know that y is 0, but I don't know x. So I'm trying to find x. That makes this our x-intercept. I can use the exact same flaw, or the exact same strategy that I just used on the previous one. In this case, y is 0, so I can just simply take it out of the equation. I see 3 times something is equal to 15. That means that all I have to do here is divide by 3, and I know that x is going to be equal to 5. Okay, hopefully that helps out with it, and it gives you the opportunity to be able to do this fairly easily, fairly quickly. You have a couple you need to do on your own. The final part says create a graph and plot these points to find the slope of the line that goes through them. Yeah, that's one way to do it, is create a graph. I think in this case, since I don't have any graph paper or anything, I think there is a simpler method to do that. And that's just by taking a couple ordered pairs, such as 2, 9 and 4, 3, just the first two. And I can find the change in y over the change in x. So I can take this and I can go 3 minus 9 divided by, so I'm going this way from 3 to minus 9, and 4 minus 2. And I find out that's negative 6 halves, which I know can be simplified to negative 3. Now, before I just say, yep, that's the answer, theoretically, I should be thinking of another point on this graph to make sure that that really holds true. So I'm going to go ahead and compare 0, 15. And let's just do 5, 0. Let's compare our intercepts. So what I'll do with this one is I'll go ahead and go 15 minus 0 divided by, so I'm going this direction, 15 minus 0 and 0 minus 5. And I get 15 divided by negative 5, which equals negative 3. I've checked 2 different sets of ordered pairs to find the slope, and I see that the slope comes out to the same value, so I know that I have the correct slope value. Question 4. It says match each set of equations with the move that turns the first equation into the second equation. So what we're doing in this one is we're looking at each of these 5 items down here, and we're checking to see which one of these moves made the equation just above change to what it is. So it's going to be a little tricky, but it's also meant to show you that there's a lot of different options for solving equations and a lot of different ways to make the first step. Looking here at the very first one, we see that 6 times x plus 9 is equal to 4 times x minus 3. What I first notice is this 4x is eliminated from the expression in the right in the second step. So what I need to think about is how would we eliminate that from that first step? And the only way to eliminate something completely to make its value equal to 0 would be to take its opposite. So in this case, since I see a positive 4x, the opposite of that would be to subtract 4x from here. And then on the left side, if I've subtracted 4 times x from 6x, I do in fact get 2x. And so what I would look for down here on the bottom is I would find the one that says subtract 4 times x. I don't see any of them that say subtract 4 times x, but I do see one that says add minus 4 to both sides and add minus 4x to both sides. This is what we call the additive inverse. So if I do this as a principle of saying I add a minus 4x to the right and I add a minus 4x to the left, I get the exact same outcome. And so what I know about this one is the very first one is add 4 times x to both sides. Okay. The next one, the first thing that I notice from this one is that the grouping 5 times x minus 7 has lost that minus 4. Now, how could that happen? Well, we have the very first thing I think of is this minus 4 is being multiplied by that grouping. So what's the opposite of multiplication? It's division. So I have a couple of options. I could see this as dividing by negative 4. And that would eliminate that term from this side. But I also know the same thing as dividing by negative 4 is multiplying by 1/4. So I need to look for one of those options to take 1/4 of negative 4. Excuse me, that should be negative 1/4. If I look at that to multiply by a negative 1/4 or divide by negative 1/4, meaning the exact same thing, that will eliminate that negative 4 from the situation. I go to look at the bottom here, and I see that I have a multiply both sides by negative 1/4, multiply by both sides by a positive 1/4. I need to use the negative 1/4 because the coefficient here began as a negative, and I want to always use that same value when I'm talking about our multiplication or division properties. So I know that multiplying by a negative 1/4 would be this situation. The next problem, I want to look to see what changed. This did not change, neither did this. So the question is, how did I get from 8 to 4 and 7 to 3? Well, there's a common difference there in both of them. That common difference from 8 to 4, the only way to get there is to subtract 4, and 7 to 3, I see a subtract 4. So I know that if I have that value, as we discussed in the very first one, I can also think that as an add negative 4 and an add negative 4 there. Looking what I'm left here on the bottom, I see that I have an add negative 4 down here on the bottom. All right, the last two. Multiply by negative 4, multiply by 1/4. Well, which one looks a little more difficult? I think this one with the fraction looks a little more difficult. That sounds like a good one to go ahead and go after, because I think that that's something that we'll probably shy away from. I'm not going to look at the fraction though. And this is why I'm talking about this one. I want to look here at the side that makes a little more sense to me right there. How do I get from 4 to negative 16? If I take negative 16 and divide by 4, I can get negative 4. So that means that negative 4 times, or excuse me, positive 4 times negative 4, that works. I also could have subtracted 20 from positive 4, but that's not an option. All I'm left with is multiply. So in this case, all I can do is multiply by negative 4. And then what I know is this one would be true. And that would say my very last one. Multiply both sides by 1/4. Should hold true here. 12 times 1/4 is 3. 4 times 1/4 is 1. 20 times 1/4 is 5. 24 times 1/4 is 6. I know I've got them all. Final question. Select all the situations for which only 0 or positive solutions make sense. Measuring a temperature in degrees Celsius at an Arctic outpost each day in January. Well, we know the key term right here, Arctic outpost. That sounds pretty chilly to me, and I'm sure that we're going to get minus temperatures or negative degrees. The height of a candle as it burns over an hour. Well, what's happening to that candle as it's burning? We know that that candle as it's burning is dripping wax. So if it's dripping wax, that height is decreasing over time. So we know that one can't be a positive solution. Meaning, or the reason for it is because over time, every single hour, the height is going to decrease. The elevation above sea level of a hiker descending into a canyon. Well, we're going to see that person looking at this going down into a canyon. That one's going to be negative, not 0. The number of students remaining in school after 6 p.m. After 6 p.m., let's think about that. How many students could remain in school after 6 p.m.? We hope that they're all home, but there's a question of how many people are still there. That one, not quite sure about what to think on there. I'm gonna let you decide on that one, take a risk, but I want you to pay attention to a couple of things. The number of students remaining in school after 6 p.m. If they're remaining in school, that means that the number kind of dropped down and then stopped changing. And we're only talking about this part right here, where the value stopped changing. That should be a major hint to you about something. A bank account balance over a year. Well, if it's my bank account balance, that could be ugly. But if we're looking at this one, I would definitely say that's a positive solution because bank accounts tend to increase. The temperature in degrees Fahrenheit of an oven used on a hot summer day, that one's going to have to increase as well. So I would say that D, E, and F are the true answers. Let's find out. We'll hit done and review. Oh, it says I did 2 questions incomplete. That's all right. And here we go. Let's see if our scores are on here. I don't know if it does this for me or not. I've never actually done this before. Okay. So the first one, just because I didn't mark it on there, I'm really actually only interested in the last one. Oh, I was wrong. The bank account balance over a year, because this one right here can definitely change up and down. That's the only one that I was really missing on there. So, but I also missed this one. The height of a candle as it burns over an hour. I'm not sure how that one has a positive solutions. I'll have to think about that one, but now we all know that it's a D, D, and F. My mistake. I hope this is helpful for you today. Thanks for tuning in. Make sure you have a great day. Oh, and make corrections on this in McGraw. Take care.